Bismillahirrahmanirrahim. Assalamu alaikum. Dear students of grade 10, welcome to your chemistry class. Today we are going to complete the topic types of salts as our lesson number 2, because in lesson number 1 we have completed first 3 types of salts, which were normal salts, acidic salts and basic salts. Now in this lesson we are going to complete the remaining 3 salts, which are double salts, mixed salts and complex salts. This topic is given in chapter number 10, acids, bases and salts, on pages 41 and 42 of your textbook. So the remaining 3 salts are double salts, mixed salts and complex salts. First we are going to discuss the double salts, that how these salts are prepared. So double salts are formed by the normal salts, in which the 2 normal salts are mixed together. 2 normal salts or neutral salts are mixed together and they are actually formed in water. So when 2 normal salts are mixed in such a manner that they are dissolved to make their equimolar saturated solution. Equimolar saturated solution. Equi means equal, molar mean molarity. So जब दोनों नॉर्मल सॉल्ट्स का हम सैचुरेटेड सॉल्यूशन इस तरह से तैयार करें कि जिसमें दोनों की अमाउंट या मोलैरिटी या उनका जो मोलर सॉल्यूशन हम तैयार कर रहे हैं वो इक्वी यानी बराबर हो, इक्वल हो. अगर हम 2 मोलर सॉल्यूशन किसी एक सॉल्ट का ले रहे हैं तो दूसरे सॉल्ट का भी हमें 2 मोलर ही लेना पड़ेगा. सो इक्वी मोलर सैचुरेटेड सॉल्यूशन को हमने क्रिस्टलाइज करना है. एंड व्हाट इज़ क्रिस्टलाइजेशन? जिसमें when we will able to prepare the saturated solution in water, then heat that saturated solution, so water will be evaporated, जिसमें से water evaporate हो जाएगा and the remaining thing which is left behind will be only the crystals of double salts. Important thing in this case is when these 2 normal salts are participating, then individual salt will retain its property, that it will not lose its property. इनमें 2 नॉर्मल सॉल्ट जो इस्तेमाल हो रहे हैं वो जब डबल सॉल्ट्स की तैयारी के लिए जाएंगे तो डबल सॉल्ट के अंदर ऐसा नहीं होगा कि दोनों नॉर्मल सॉल्ट अपनी अपनी प्रॉपर्टीज़ जो हैं वो खो दें. अगर एक नॉर्मल सॉल्ट की प्रॉपर्टी किसी कलर के हवाले से और दूसरी जो है वो इसकी स्मेल के हवाले से या किसी फ़िज़िकल और कोई भी फ़िज़िकल प्रॉपर्टी के हवाले से, तो उसमें दोनों नॉर्मल सॉल्ट अपनी अपनी जो फ़िज़िकल प्रॉपर्टीज़ हैं उनके साथ जो है वो अपीयर होंगे. कोई भी सॉल्ट अपनी प्रॉपर्टी डबल सॉल्ट की फॉर्मेशन के लिए लूज़ नहीं करेगा. And another important thing के anions and cations give their respective test. यानी जो भी डबल सॉल्ट के लिए anions या cations फॉर्म होंगे, anions और cations जो कि डबल सॉल्ट में मौजूद होंगे वो अपने रिस्पेक्टिव टेस्ट की मदद से आइडेंटिफाई भी हो सकते हैं. सो anions और cations give their respective test. And some of the examples of double salts are now given in front of you in this way. For example, the first salt is, now examples you have to write down heading. First salt is Mohar salt, Mohar's salt, and the formula of this salt is iron sulfate FeSO4 with ammonium sulfate with 6 water molecules which are called the water of crystallization. So these are 2 salts, FeSO4 along with NH4 taken twice, SO4. So these are two normal salts which are collectively form this double salt, which is commonly called Mohar salt. Second example of double salt is, you can write potash alum, and commonly it is called Phitkery. So this is white colored salt, and also an example of double salt formed by the two normal salt, in which one is called potassium sulfate along with aluminium sulfate. So Al2SO4 taken thrice along with 24 water molecule, which are called the water of crystallization. Third example of double salt is called ferric alum. And the formula of ferric alum is starting from potassium sulfate along with Fe2SO4 taken thrice along with 24 water molecules, which are again water of crystallization. So these are some of the examples of double salts, including Mohar salt, potash alum, and ferric alum. Next type of salts are called mixed salts. Mixed salts contain more than one basic or acid radical. So they contain more than one acidic or basic radicals. For example of mixed salt is bleaching powder. Now, formula of bleaching powder is CaOCl and again Cl, in which you can observe, or you can also write the formula in this way: CaOCl taken twice, and this twice represents that the number of, that is more than one acidic or basic radicals, means that number of acidic radicals are 2 while the basic radicals is only 1. Or somehow you can say that calcium has 2 positive charge on it while the chloride has -1. Even the oxygen has 2 negative charge on it. In this case, you can observe that the number of acidic radicals are more than the basic radicals, and their number is more than 1. That is, the 2 chloride ions are participating in the formation of mixed salts. So when mixed salts are formed, actually they have more than one acidic or basic radicals, and in this case, in case of bleaching powder, the acidic radicals are more than 1 in number. Is this thing cleared? Now, sixth and the last type of salt is called complex salts, and these salts are formed by the combination of a simple cation along with complex anion. And you know very well that cations contain positive charge and anion contains negative charge on them, and only the simple ions produces the characteristic test for cations and anions. And this is another property of the complex salt, that they on dissociation provide a simple cation and a complex anion, or vice versa. For example of complex salt is now potassium ferrocyanide is an example of complex salt. Potassium ferrocyanide, and the formula of this salt is, that is the formula unit you can also say of this salt is K4FeCN taken 6. Now potassium ferrocyanide gives on ionization a simple cation which is K4. So K4 is a simple cation, while the remaining part of this formula, that is FeCN taken 6, is actually complex anion. And when we will write this anion, we will write in this way: FeCN taken 6, and also mention here -4. What is the reason why I am mentioning here -4? Because the valency or the charge present on potassium is +1. Here I am writing 1. So potassium having a +1 charge on it, and also you can observe four numbers of potassium are participating in making complex salt, that is potassium ferrocyanide. So these fours are exchanged with the complex anion, and here I am writing -4, which is indicating that FeCN taken 6, 4 anions are also used in the formation of potassium ferrocyanide. So this part of the complex salt is called the cation, that is the simple cation, while the remaining part up to here is called complex anion. So these are some of the types of salts which we have discussed in this lesson.